We are going to study Science and Technology part first. But before that, do subscribe my channel and click the bell icon for notification. Chapter 5, Heat. In the previous standard, we have learnt about heat and different types of heat transfer. We have also performed few experiments related to expansion and contraction of solids, liquids and gases. We have learnt about the difference between the heat and temperature. We have also seen how temperature is measured using a thermometer. So now in this video, we are going to learn the concept like latent heat of phase transformation. Latent heat. In order to understand this concept, let's perform an activity as shown in figure 5.1. Take a few pieces of ice in a glass beaker. Insert the bulb of a thermometer in ice and measure its temperature. Put the beaker on a stand. Heat the ice using a burner. Record the temperature using the thermometer after every minute. As the ice is heated, it starts melting. Stir the mixture of ice and water. Continue the heating even after ice starts melting. Then draw a graph of temperature versus time. Take a look at graph of temperature versus time. What do you observe? Well, you will observe that temperature of the mixture remains 0 degrees Celsius till the ice melts completely. If we continue heating, even after the conversion of all ice into water, the temperature of the water starts rising and reaches 100 degrees Celsius. At this temperature, water starts converting into steam. The temperature of the water remains constant at 100 degrees Celsius till all water converts into steam. The graph of temperature versus time is shown in the figure 5.2. Look at the graph. Line AB represents conversion of ice into water at constant temperature, that is at 0 degrees Celsius. When ice is heated, it melts at 0 degrees Celsius and converts into water at this constant temperature. The ice absorbs heat energy during this transition and the absorption of energy continues till all the ice converts into water. The temperature remains constant during this transition. This constant temperature at which the ice converts into water is called the melting point of ice. Thus, during transition of solid phase to liquid, the object absorbs heat energy, but its temperature does not increase. This energy, or rather heat energy, is utilized for weakening the bonds between the atoms of molecules in the solid and transforms it into liquid phase. The heat energy absorbed at constant temperature during transformation of solid into liquid is called the latent heat of fusion. Thus, in short, ice gets converted into water at constant temperature, that is 0 degrees Celsius, this constant temperature is called the melting point of ice, and the heat energy absorbed during this transformation is called latent heat of fusion. So, we define latent heat of fusion as the amount of heat energy absorbed at constant temperature by unit mass of a solid to convert into liquid phase is called the specific latent heat of fusion. Now, once all the ice is transformed into water, the temperature of the water starts rising. It increases up to 100 degrees Celsius. Take a look at graph 5.4. The line BC in the graph represents rise in the temperature of water from 0 degrees Celsius to 100 degrees Celsius. Thereafter, even though heat energy is supplied to the water, its temperature does not rise. The heat energy is absorbed by the water at this temperature and is used to break the bonds between the molecules of the liquid and converts the liquid into gaseous state. Thus, during transformation from liquid phase to gas phase, heat energy is absorbed by the liquid, but its temperature does not change. The constant temperature at which liquid transforms into gaseous state is called boiling point of the liquid. The heat energy absorbed at constant temperature during transformation of liquid into gas is called latent heat of vaporization. As we had studied in latent heat of fusion, similarly, water gets converted into steam at constant temperature, that is 100 degrees Celsius. This constant temperature is called boiling point of water, and during its transformation from water to steam, or rather from liquid phase to gas phase, heat is absorbed. It is called as latent heat of vaporization. So we define latent heat of vaporization as the amount of heat energy absorbed at constant temperature by unit mass of liquid to convert into gaseous phase is called the specific latent heat of vaporization. Different substances have different melting points and boiling point. The value of melting point, boiling point and latent heat depends on the atmospheric pressure. In the following table, the melting point, boiling point, specific latent heat of fusion and vaporization of few substances is given. As of water or ice, melting point is 0, boiling point 100 degrees Celsius. Specific latent heat of fusion 333 kilojoule per kg, which is also equal to 80 calorie per gram. Specific latent heat of vaporization is about 2256 kilojoule per kg, equivalent to 540 calorie per gram. Similarly, the values for copper, ethyl alcohol, gold, silver and lead are also given. Pause the video for a minute and take a look at the table. Regelation. You may have seen the preparation of an ice ball. First, an ice slab is shredded, and then the shredded ice is pressurized around the tip of a stick to prepare the ice ball. How does the shredded ice convert into solid ice ball? If two small pieces of ice are taken and pressed against each other for a while, they stick to each other. Why does this happen? Let's understand this by performing an activity. As in figure 5.3, put a slab of ice on the stand. Hang two equal weights to the two ends of the metal wire and put the wire on the slab as shown in the figure. What do you observe? Well, it is observed that wire gradually penetrates the ice slab. After some time, the wire comes out of the lower surface of the ice slab. However, the ice slab do not break. The phenomenon in which ice converts to liquid due to applied pressure and then reconverts to ice once the pressure is removed is called regelation. The melting point of ice becomes lower than 0 degrees Celsius due to pressure. This means that at 0 degrees Celsius, the ice gets converted into water. As soon as the pressure is removed, the melting point is restored to 0 degrees Celsius and water gets converted into the ice. Thus, in short, regelation is a process in which pressure is applied on the ice. Its melting point reduces to less than 0 degrees Celsius. It gets converted into water, and again when the pressure is removed, the melting point is restored and water again gets converted into ice. Here are few practice questions given. Do answer these questions. If you have any doubt regarding this chapter, do ask in the comment section below. Do like and share the video. Thank you.